All right, so the first thing that I want to talk about, okay, is the meaning of force. Okay, can anybody tell me what is the meaning of force? Please don't make me call your names. Force is a
Push and pull.
okay. Force is a push and pull. Thank you. Okay, this is the first thing that you need to understand lah. Okay, it's a very simple concept lah. Kan? You push something, you pull something. You are actually exerting what we call a force lah. Kita mengenakan satu daya. Okay, dalam bahasa Melayu, daya is force lah. Okay, so that's number one. Secondly, force, the force that you feel or the force that you put on somebody, is that I slap your face. I like to use slap face because I'm very dramatic. You know, you slap somebody's face or somebody slap your face or you slap each other's face or whatever. Kan? Okay, that's also a form of force. But force is dependent on two very important things. Okay, can anybody tell me what is it dependent on? Force depends on two very important things, which is balance or unbalance. Okay, that's actually the third thing. But can we talk about balance forces, okay, and unbalanced forces, but in a while. Okay, come on, force depends on two very important things. Anybody?
Mass and acceleration.
Very good. Okay, force depends on two very important things, which is mass and acceleration. Now, the concept of acceleration, you have studied with teacher Fiona. I hope you still don't forget lah. Acceleration is how much faster you are going, okay, over a certain period of time. So please don't confuse between acceleration and velocity. Okay, velocity is just how fast you're going, but acceleration is how faster you are getting. Yeah, this is a very simplified way of saying okay, how much faster you're getting or how much slower you're getting over a certain amount of time. Okay, can anybody tell me the relationship between mass and mass and acceleration? Sorry, the relationship between mass and acceleration. Sorry, I'm going to stop for a while. I want to talk about the relationships. There are two very important relationships when it comes to this concept of force. Okay, the first one is between mass and acceleration. Can anybody tell me what is the relationship between mass and acceleration?
Inversely.
The bigger the mass, the smaller the acceleration.
Okay, so I hear two kinds of answers. The first kind of answer is the bigger the mass, the smaller the acceleration. That's very good. Okay, now somebody said inversely proportional, and that is actually also correct. Okay, it means the same thing lah. Okay, inversely proportional. Sorry, my pen is not cooperating with me today. Either that or my pen also is like me. Can only wake up after 9 o'clock. Okay, so inversely proportional means when one goes higher, the other one goes lower. Okay, what is the opposite of inversely proportional? Anybody knows? What is the opposite of inversely proportional?
Directly.
Okay, very good. Directly proportional. Directly proportional means when one goes up, the other one also goes up together. Directly proportional. Inversely proportional, one goes up, the other one goes down. Which is in this case, okay, when you increase the mass, your acceleration will decrease. And that's very logical. Who's the smallest person in this class? I think this one of the smallest person in this class is Joey. Okay, so for example, let's say me and Joey. Okay, Joey is obviously, her mass is much more smaller than me. Sorry, those of you who don't know Joey, maybe Joey, you can wave your hands because not everybody knows him. Okay, so that's Joey. So Joey is very tiny so terrible. Okay, Joey is very tiny. Maybe she's not 137 centimeters like somebody else but you know, she's very tiny and she's very light compared to me. I'm like 82 kg. Okay, so my mass is very big. So if let's say both Joey and me, if we both run the 100-meter race, right, who will be able to accelerate faster? Obviously, it will be Joey because her mass is so small. So the smaller the mass, like Joey, the faster her acceleration. She can get faster, even faster compared to me because I have so much fat, so it's like, okay, it will take me a very long time to become faster. Okay, so obviously, if me and Joey, we run the 100-meter race, most likely Joey will win Because she can accelerate faster than me. Because she has less mass. The bigger the mass, the smaller the acceleration. Okay, it's very logical. You think about it. Okay, somebody who is bigger mass, okay, is going to harder to become faster lah. Okay, that's basically acceleration. Okay, the second relationship is the relationship between force and acceleration. Okay. Sorry, I don't know what is wrong with my pen today. Okay, force and acceleration. Can anybody tell me what's the relationship? What's the relationship between force and acceleration?
The bigger the force, the bigger the acceleration.
Very good. Okay, the bigger the force, the bigger the acceleration. For example, if you want to push, let's say you go to the supermarket, okay, and you got nothing better to do while your mother is shopping, then you want to test and see whether the trolley, how far the trolley can go if you push the trolley and then let it go. It's kind of the no-brain thing to do, but I don't know how many of you have done this. When I was much younger, because I come from KL, so there's one very famous tempat membeli bela not tempat membeli bela, place to buy vegetables, supermarket So the supermarket is famous because the aisle is very long one. So you have rows and rows and rows and rows, but all the aisles very long. So one day my brother and I, we were so bored. So we decided to have a race. We decided, okay, come, let's push this trolley. We just push it in, then we just stand there and then see how far the trolley can go. Of course, we got scolded. Okay, we got scolded very thorough. But it was fun because I had the lighter trolley and my brother had the trolley with all the heavy stuff. There's a lot of drinks, there's a lot of bottles and chicken and everything. Mine was almost empty because mine was the second one. So I said, okay, come, we fight. Maybe you push stronger, but I push not so strong. But actually both of us pushed the same strong. So in the end, what happened was, you think about it, okay, let's say long aisle, right? Okay, I push and then my brother push. Whose cart will sorry, wait, this is force acceleration. Sorry, force acceleration. Oh yeah, I was talking about mass acceleration. Okay, so let's say you push this one. Okay, if let's say I push with a bigger force, obviously the trolley can go very far because you're pushing with a bigger force. Okay, but if you push with a smaller force, let's say like that, anything you push, okay, then obviously the trolley cannot go very far because the force that you put on the trolley is very little. Okay, so the second relationship, the bigger the force, okay, the bigger the acceleration, the faster it is able to get faster. Okay, that's basically what acceleration is now. Okay, so these two relationships are very important. Okay, mass and relationship are inversely proportional. When the mass is bigger, the acceleration is smaller, and the other way around. Second one is the force and the acceleration are directly proportional. Okay, bila kamu punya daya adalah besar, bila kau kenakan daya yang besar, kamu akan mendapat pecutan. Astaga, directly. Sorry, my pen is totally not cooperating with me today. Okay, proportional. Okay, yeah, that's proportional. See, if you can read it, you can read it. Okay, so force, the bigger the force, the bigger the acceleration. And these two relationships bring us to this guy's law, which is Newton's, Newton's, okay, sorry, I don't know why my pen is not cooperating with me today. Okay, Newton's second law of motion. What does Newton's second law of motion say? Wait, did I talk about Newton's second law of motion in my video? Or was it the next class?
Yes.
Did I talk about? Oh, I did. Okay, can somebody tell me what is Newton's second law of motion?
The rate of change of momentum is directly proportional to the force and acts in the direction of the applied force.
Okay, so for today, one of the things that I want you to do is to memorize this law. Actually, Newton is our very good friend. Because of Newton, you are studying physics. Okay, let's talk about balanced and unbalanced forces. I want to know one very important thing. When balanced, what is the biggest difference between a balanced and unbalanced force? Anybody? Maybe this one that you can tell us because you're the one that spoke about this. Sorry, what did you say?
One force must be
Huh? What? What did he say? When the forces are balanced, what's the biggest difference between balanced and unbalanced forces? This is a very important thing for us to know. Anybody?
The acceleration is 0.
Which one?
Balanced.
Very good. Okay, when the forces are balanced, there is no acceleration. Okay, acceleration equals to 0. When the forces are unbalanced, okay, then there is an acceleration. Okay, and the unbalanced force, we call this a resultant force. I'm going to kill my pen, seriously. Okay, resultant force. My pen is so not cooperating with me today. Okay, so unbalanced forces result in a resultant force. And when there's a resultant force, when the resultant force is not 0, then there is an acceleration. And this is a very important thing. I want you to differentiate between acceleration equals to 0 and acceleration is not equals to 0, means there is an acceleration. When acceleration equals to 0, there are two situations. Okay, there are two possible explanations for the situation. When something is not moving with an acceleration, what can it mean? Anybody? There are two situations where acceleration is 0. Either the object is what? Anybody want to try?
Not moving.
Okay, not moving. Very good. Okay, not moving. Not moving is the standard way to say this very important physics word, which is stationary. Okay, N-A-R-Y, because N-E-R-Y is alat tulis. Okay, when something is not moving, we say that the object is stationary. Okay, it's not moving. But yeah lah, and it's logical lah, kan? If the object is not moving, how to accelerate, how to become faster, kan? Okay, but there is also another situation where the acceleration is 0. Okay, can anybody try? Want to try? I'm not sure.
Constant velocity.
Okay, very good. Okay, object is moving. Is moving, okay, is moving with constant velocity. Okay, now this is a very important thing. It doesn't mean that if you are not accelerating, means you're not moving. You know, sometimes you're moving, but you're just moving, but you're not getting faster. Let's say, for example, you're driving a car, and then the needle, you know the odometer, the one that says 0 over here. And then when you get faster and faster and faster, let's say it goes all the way to, let's say, 100 kilometers per hour. Let's say, for example, you're driving and you're forever staying at 50 kilometers per hour. Okay, and you're not going faster, you're not going slower. That is a situation where the acceleration is 0. Are you moving? Yes, you are moving. Okay, but you're just not getting faster. You're maintaining the speed. And in physics, we call this constant velocity. The velocity is unchanging. Kamu punya kelajuan tidak berubah. Okay, tetapi kamu bergerak. Okay, you're just not getting faster. And that is an acceleration equals to 0 moment where the forces are balanced. Okay, now this one, until Form 5, there will be some people who still cannot get this around their head. So I will have this, you have to kind of drill this in your head, because sometimes it's difficult for us to differentiate between acceleration and velocity. Okay, velocity is how fast you're going. Acceleration is how much, not how fast you're going, how faster you are going. Oh no, sorry, this terrible explanation. Okay, so anyway, those are the two important situations when the acceleration is equals to 0. Okay, and most of the time people forget this second one. Okay, so please remember this. Acceleration not equals to 0 doesn't matter. Okay, it's definitely getting faster. Okay, that's the important thing. Okay, last one. What is the formula that is involved? that you're supposed to know? There's only one formula. What is it? The formula for force, people? Sorry?
F equals to MA.
Okay, very good. F equals to MA. M represents the mass. Okay, A represents the acceleration. What is the unit for force?
Newton.
Okay, the unit for force is Newton or just a big letter N lah. Okay, but this force is not just force, you know. It's actually the resultant force. Okay, and if you watched the video yesterday, you would have seen that the resultant force you have to consider all the forces, then the front minus the back, depending on where the acceleration is lah. Okay, so today, with whatever time we have left, I want to discuss a couple of exercise questions. Okay, just to help you to understand how to use this concept of forces, okay, in questions. And then at the end of this class, I think it should be in the Google Classroom by now lah. I've already posted your homework in the Google Classroom. So and I will talk about it at the end of the class lah. Okay, so let's consider this first situation. So you have a cyclist, and cycling his bicycle with a force of 120 newtons. Okay, why is there 20 newtons to the behind, to the back? What is this force called?
Frictional force.
Okay, very good. This is called a frictional force. Okay, because in our real world, everything got friction one. Friction dalam bahasa Melayu is geseran. Okay, whenever frictional force is an opposing force lah. Okay, so if you want to go forward mesti ada benda yang menarik kamu ke belakang. There's always going to be a little bit of opposition. Okay, and in terms of force, frictional force is one of the forms of opposition. Okay, so we have to consider this situation. The first thing we need to do is we need to count the resultant force. Okay, count the resultant force and then put it into the F equals to MA. Okay, the mass is 80 kgs lah, because already given total mass of bicycle is to 80 kgs. Can you calculate the acceleration for me, please? Okay, can I have Carlson to answer this, please? Carlson seems like somebody that...
1.25 meter per second square.
1.25 meters per second squared. Okay, let's double check. All right, so it is lah. Okay, it is 1.25 meters per second squared. So remember that the force, okay, you need to calculate the resultant force first. Okay, then only you can put it into the F. Okay, so a common question is, orang akan nampak ni 120 kan, then straight away put the 120 in here, tapi dia lupa pasal frictional force. Remember, always count the resultant force first before you put it into the F equals to MA. Okay, all right, good job. Next, which of the following systems will produce the maximum acceleration? Okay, so remember, if the mass is the same, okay, if you want a maximum acceleration, what kind of resultant force do you need? Okay, that's why you have to remember the relationship between force and acceleration. Okay, take a look at this question, and then I will call somebody to give me the answer.
D.
D. D as in donkey. D, this one lah.
Yeah, donkey.
Okay, why? Why do you say that?
Because the force is bigger.
Because the force is bigger. How much is the force over here?
24.
24. To which direction? To the right or to the left?
To the right.
To the right. Okay, let's verify and see. Okay, good. The answer is D lah. Because if you consider all situations, this A situation is 20 newtons only, because 100 minus 80. Look at the arrows, people. 100 minus 80 is 20 newtons to the right. This is 12 and 8, but it is in the same direction. So this is negative 20 newtons, and it's going to the left, because negative lah. This is 5 and 15. This is 20 newtons. Okay, but since they are in the same direction, it will be to the right. Okay, so Chen He has gotten this correct lah. Okay, it's 24 newtons to the right, even though they are opposing one another. So we want to look at the resultant force Because we said just now, the bigger the force, okay, the harder you push the trolley, the faster it's going to go, the bigger the acceleration. And we want that. Okay, next question. Diagram shows a Formula One racing car. Okay, so the question is, why does the car designs engineer use light composite materials? Light means what? Okay, for making the body of the car, although the engine is powerful. Take a look at the 4 answers and tell me which answer is the best answer you think for this particular situation.
B ka teacher.
Why B? B is a small mass produces a large force. Really? Interesting. Okay, so thank you for the answer. Let's give it a try. I think it makes sense. A small mass produces a large force. Does it? If you want to talk about mass, always remember the biggest comparison is always me and Joey. Okay, Joey is very light and I'm very heavy. Are you sure Joey is going to be able to produce a large force compared to me? Oh, how? Okay, so actually I would say that this is untrue lah. Okay, because the two relationships we learned are about mass and acceleration and force and acceleration. We don't talk about the relationship between mass and force. Okay, so it's not B lah. Actually, the answer is A. Acceleration increases if the mass decreases. How do you know that the mass decreases? Because of the word light. Okay, light maksudnya ringan bukan? So that means mass dia berkurangan. And just now I said when the mass is small, the acceleration will be big. Okay, so this will be the answer. Okay, good try anyhow. Okay, but we can learn to improve here lah. Okay, so don't be afraid to make mistakes because class lah is where you make mistake. Takkan you want to make mistake during exam kan? Okay, question number 4. Diagram 4 shows a car with a mass of 1,000 kilograms. So this is the mass. Okay, acceleration of 2 meters per second squared. There is a frictional force of 900 newtons acting on the car. So what is the force that is going forward? Okay, think about it. Think about it. And I'll give you some time to count. And I will call somebody again to answer. We still use the same formula, okay, which is F equals to ma, in case some of you have forgotten.
B.
B. Okay, can you tell me how you got this answer, B?
I take the one at the mass.
Okay.
Darab the 2 ms
Okay.
itu. Then minus
Okay, so you get
900
2,000.
N.
Oh, okay. So the resultant force is 2,000. Then you minus 900.
Is that true?
Okay. Yeah. I think it makes sense. Totally makes sense. See, T minus 900 lah. So the resultant force in this situation, the resultant force on the left is the front force, and they give the letter T lah. Tiada masalah lah. You can give any letter you want, but it's minus 900 because obviously the acceleration is going towards the front lah. Okay, so it's the front force minus 900 equals to, and Diana got this right. Okay, you multiply the 1,000 times 2. Then you move the 900 over, it becomes plus. Oh, yeah, it becomes plus. It shouldn't become minus. Okay, so actually it's 2,900. So you almost got it there actually. Dia bukan minus because over here dia minus bahkan. Bila kau pindah pergi sebelah, dia kan jadi tambah. It becomes plus. So it becomes 2,900 newtons. Okay, so I think you got the concept over there. You just need to make sure that bila kau pindah, kamu memindah dengan betul. Because remember, this one, the 2,000, is already the resultant force. Sudah kena tolak dengan 900. Jadi saya mau tahu berapa yang menolak dengan 900. How much is being minus 900? So it's actually 2,900. Okay, good try, no problem. All right, number 5. F1, F2, F3 are forces with the same magnitude acting on the same block. Same magnitude means what? Can anybody tell me what is the meaning of the word same magnitude? Totally no idea. Everybody want to Google what is the answer. Don't know what is magnitude. Okay, magnitude basically is just a value. Okay. If you remember in chapter 1, all physics quantities are scalar quantities and vector quantities. Both scalar and vector quantities got magnitude. The only difference is vector quantity got direction. So magnitude is basically a value lah. Okay, so same magnitude means if F1 is 10 newtons, okay, F2 is also 10 newtons and F3 is also 10 newtons, except that the direction is different. So my question is, which diagram shows the maximum resultant force, okay, acting on the wooden block? Take a look at this question and try and see. I want the maximum resultant force. Sorry, I don't know. Oh, sorry. Oh. Why A?
Because
She don't want to talk about it
they're
now.
all pointing at the same direction.
Okay, very good. They're all pointing in the same direction. So obviously maximum resultant force. Okay, biggest force is when they're all pointing in the same direction. The moment you have something opposing you, okay, you are going to get a smaller resultant force. Okay, very good. So I suppose it's Bernardine lah, because she don't want to tell me what is the correct pronunciation. Never mind. Okay, diagram 5 shows a toy car of mass 4 kg. Okay, the car is pushed with a forward force of 10 newtons. The frictional force is 2 newtons. Tell me what is the acceleration. Same formula, F equals to ma. But remember, calculate first the resultant force. Okay, Raman? Oh no, that means you have to type out the answer. What is the answer for this, number 6? D. Okay, let's double check lah. So, okay lah, correct, is D. So 10 minus 2, and then you divide it with the mass, which is 4 kilograms, so you get 2 meters per second squared. Okay, good job. All right, let's take a look at a slightly different kind of question. This is the same as almost the same as the one that I discussed in the video. Okay, but I want you to try to look at this lah. So diagram 6 shows 2 identical boats. Okay, you have 2 identical boats, except that in R, you have 2 passengers, but only one person is working hard. The other person is just sitting down and doing nothing, you know, just totally binging off the first person. Sorry, hold on. Okay, sorry. Then the second boat, okay, has 2 people and both are paddling. Okay, and this is very logical. In 1 minute, the distance traveled by boat R is 80 meters. Okay, and the distance traveled by boat S is 150 meters. So the first one is, what is the force that acts between the boat and the water? Okay, anybody want to try this? Between the boat and the water, what is the force that is acting, you know, here? Anybody?
Frictional force.
Okay, always frictional force. Okay, I'm not sure if you have been told this, but maybe I should tell you now. So frictional force is usually between an object and a certain surface. Let's say, for example, if you're rubbing your hand against another hand, right? So that's frictional force lah. Okay, the boat and the water is frictional force. But when we are talking about air, okay, let's say air as in udara. Okay, let's say you're talking about this guy's head and the force that is opposing the guy's head. So this one now we call this as air resistance. Okay, so air resistance is the resistance between the object and the air. Okay, and we cannot say that air resistance is the same as frictional force because you're not rubbing against another surface. You're rubbing against the air. Okay, so be very careful with this lah. If the question say what is the force that acts between the boat and the air, then you say air resistance. Okay, because it's resisting the air lah. Okay, but since this question is the force that acts between the boat and the water, which is another surface. Okay, so we call this frictional force. Dalam bahasa Melayu it's called daya geseran. So dia bergeser. Okay, the boat and the water is menggesering. Gesering. Okay, between one another. So that's how we would do this now. Okay, second question. So based on this diagram, okay, I want you to compare the force, compare the distance, compare the acceleration. Let's talk about the force first. Who has the bigger force, R or S?
S.
Okay, S has the bigger force. So how would we answer this? We would say that the force, okay, the force applied to both S, okay, is bigger than the force applied to both, astaga, both R. I don't know if you can read my ugly handwriting, but yeah, there you go lah. Okay, and I want to let you know that for this kind of questions, whenever you have to compare, okay, I want you to use full sentence. I know that in the video, the answer that they give, for example, is this like S is bigger than R. I don't want you to give me this kind of answer. Okay, give me this kind of answer. Okay, in full sentence, the force applied to both S. I mean, you know that S is bigger than R. So S ada dua orang. R satu orang saja yang mendayung. But I want you to answer in full sentence. Okay, the force applied to both S is bigger than the force applied to both R. Okay, learn to write in full sentence. Okay, secondly, compare the distance traveled by the boats. Who travels a bigger distance?
S.
Okay, also S. So you would answer in the same way. Okay, can somebody give me a sample answer for this? How would I write this answer in a full sentence? I know that S is the bigger distance. Somebody please try to answer. Just tell me the answer, like, you know. Cannot. Must call name one now. Anybody? Boat S has a bigger distance than boat R. Okay, I think I will accept that. Okay, boat S has a bigger distance than boat R. Good enough. Okay, how about the acceleration? Who will accelerate more? Yeah, okay, S will accelerate more. So the same thing lah. Okay, the acceleration of S is bigger than the acceleration of R. Okay, then after that we relate the force. Have you been taught how to write a relationship? Let's say, for example, I mean, this is a kind of SPM question. Have you been taught how to write relationships? Have. Okay, so I see some of you mengangguk kepala and some of you are like, apa itu? The only relationship I know is the relationship between me and my girlfriend. Okay, no, come on. It's not this kind of relationship. Physics relationship is nothing to do with your love life. Relate the force and the acceleration. What is the relationship between the force and the acceleration? Actually, you've learned this. You already mentioned just now. I just want to get you to talk again. Anybody? Okay, so Rahman says directly proportional. I want you to try to avoid using the words directly proportional for now. Although I understand, saya faham, dia memang betul, okay, dia memang betul, directly proportional. But is there another way to write directly proportional? The higher the okay, never mind. Diana has already answered on Ivar's behalf. Don't worry, Ivers, I'll call you for the next question, so you just be prepared. Don't think that you're off the hook. The higher the force, the higher the acceleration of the boat. Okay, good. That's an excellent answer. Okay, the higher the force, the higher the acceleration of the boat. Now, whenever you write a relationship, people, the urutan sangat penting. Okay, you have to think for a while. Is it correct? The bigger the force, the bigger the acceleration. Or is it the other way around? The bigger the acceleration, the bigger the force. You must think what you know. Does it make sense or not? The bigger the acceleration, therefore the bigger the force. No, cannot be what? Because the force is the one that creates the acceleration. It is not the acceleration that creates the force. You must push first, then you can move. And how can you get it to move and then it will push by itself? Where got such thing? No, not logical. So the force must come first. So Diana's answer is correct. Okay, except that I want you to know sometimes when you write a relationship, you must think for a little while, like, okay, is it true? Which one is the one that is affecting the other one? Okay, so be very careful with that. Okay, name the physics law involved in B4. Whose law is this? The bigger the force, the bigger the acceleration. I'm just waiting for two more words.
Of motion.
Very good. Okay, of motion. Okay, must be full one lah. Don't just say Newton's second law only. Newton's second law of motion. Okay. All right. Question D. Both lines are boats are always streamlined in shape. Do you know what is streamlined? Has anybody told you what is streamlined? So you know the shape of boats now. If you take a look at the screen, let's see. Take a look from the top now. Boats are usually like this shape. And like the front is a little bit sharper. Okay, so this kind of shape, we call this a streamlined shape. Okay, so this kind of shape where it's sharper at the front is a streamlined shape. So obviously, like the lifeboats are not really streamlined. You know lifeboats, right? Like if let's say the boat sinks, then you have these lifeboats where you have to blow. Then the lifeboat, the shape is usually like this one, like kind of an oval. So this is not streamlined because it's not really sharp at the front. But generally boats, ships, boats, they are streamlined and they are pretty sharp in front. Okay, so the reason for this, dalam bahasa Melayu, streamline is larus, bukan lurus, tapi larus. Okay, so both lines are streamlined in shape, okay, to reduce, okay, the frictional force. Okay, we want to reduce the frictional force so that you can have a bigger resultant force and therefore the boat can go faster. Okay, you want to reduce the resistance on the boat lah. Okay, so this is the reason why boats are streamlined in shape. Okay, so if anything, I want you to take this back with you today to remember this word lah, streamline. Okay, shape of the boat. Kalau dia sharp di depan kan, okay, it's called a streamlined shape. Okay, I think we have time for one more. Oh, okay, let's take a look at this lah. So the force of 10 Newton acts on the trolley, mass 2 kg. Trolley moves with a constant velocity. Which of the following statements is not true? Okay, take a look at the answers and tell me what is the answer in a while. Okay, let's have Ethan. What do you think is the answer?
A.
A. The net force on the trolley is nil. Why do you say A? Anybody else? Everybody also think it's A. Anybody else got different answer?
C.
C. The trolley will decelerate with a deceleration of 5 meters per second if the force is removed. Okay, so there is 1 vote for A and 1 vote for C. How about the rest of the 24 people here? 22 more people. Sorry?
B.
B. So everybody wants to choose one answer lah. So is anybody going to choose D? Nobody wants to choose D. Everybody choose A, B, C. Okay, let's take a look at this. I think the key word to this is the word constant velocity. Okay, that's a very important thing. And I established that much earlier. I said if something is moving with constant velocity, okay, this means that the acceleration is 0. If the acceleration is 0, the force also must be 0. Because got mass and F equals to ma. So no matter what, mass is 2 kg. But if the acceleration is 0, because of the constant velocity, the F also must be equals to 0. So actually, A is correct. Okay, the net force on the trolley is 0, correct? It's nil, it's 0. But A is not the answer because the question says which of the following statements is not true? Okay, A is true. Okay, then it said the sum of the frictional force and air resistance is equals to 10 newtons. It's also true because if you have a force of 10 newtons, that means the opposing force must be 10 newtons in order for you to get an F equals to 0. So B is also true. So far the people that have voted A and B already gonna shot down already lah. So now we see the last hope lah. Hopefully the person that answers C, this is the answer. They said trolley will decelerate with a deceleration of 5 meters per second if the force is removed. Okay, if the force is removed, then okay, if this force is removed, how much is the frictional force? The frictional force will be negative 10 newtons makan equals to 2 times A. If we remove the force, then this is a situation of unbalanced forces because there is already a frictional force. So according to this calculation, it should be 5 meters per second squared, the acceleration, because 10 divided by 2. So it seems that C is also correct, So the people that answer A, B, C, is the answer really D? The momentum of the trolley is 20 kilograms per meters, 20 kilograms meter per second. I think the answer is D. Sorry, my brain is not working now. Yeah, but I think the answer is D because A, B, and C is correct. Okay, definitely the net force is nil. Okay, the sum of the frictional force and the air resistance is definitely 10. Okay, in order to get zero force. If you remove this one, okay, the trolley will decelerate, okay, with 5 meters per second squared, because the only force that is acting now is the frictional force, which is minus 10. Okay, minus 10 equals to 2a, so a equals to 5 meters per second squared negative, which means it's a deceleration. Okay, so A, B, and C is correct. D is probably the answer that is not true. Okay, I don't think it's 20 kilograms per meter squared, but 20 kilograms meter per second. Yeah. Okay, all right, so I think that's it for today.